Alright, in the other video, I went through a problem with you guys to solve a system with elimination with one that was already set up for you. We already had those opposite coefficients and we didn't have to multiply by anything. So it was a little bit easier in terms of how to solve it, okay? So now we are going to look at some of the ones where you have to actually multiply, okay? So on page 16 in your packet, let's take a look at number 3. You may have already solved it, that's okay. You can always just grab an extra piece of paper and kind of follow along with me as I do it. So we've got negative x minus 3y equals negative 10, and negative x plus y equals negative 10. So if we look at it, we've got it lined up, right? X's, y's equals numbers, so that part's cool. But if we look, we don't have those opposite coefficients, right? We have a negative x and a negative x, a negative 3y and a positive y. Well, the negative 3 and the positive 1 are opposites, right? They're one positive, one negative, but we don't have them as the same number. So if I add those together, they don't completely cancel each other. Negative x and negative x, those are exactly the same number. So they're not opposite coefficients, they're the same coefficient. So the problem is I need to figure out how I can make one of them to be an opposite coefficient. So I'm going to focus on the x's because they're already the same number. So if I could just make one of them positive, I'd be good to go. Well, the only way to take a negative and turn it into a positive is to multiply by a negative 1. All right? If I multiply by negative 1, the only thing it does is change the signs. All right? So I'm going to take my first equation and I'm going to multiply it by negative 1. Now here's the hard part. When I do this, I have to make sure that this negative 1 goes to every single piece of my equation. So I always put the whole equation in parentheses and I draw an arrow to all 3 pieces inside. Okay? Because remember, it has to happen everywhere. So now I become positive x plus 3y equals 10. All right, so take a look at that first equation and this one I just wrote. They are exactly the same other than the signs, right? These ones were all negative, now they're all positive. Other than that, it's exactly the same. And then I'm going to take my second equation and rewrite it. Negative x plus y equals negative 10. And now when I look at it, now my coefficients on the x's are opposites. So now I know that I'm on the right track. Something that I noticed you guys are having trouble with is you're not understanding why those are canceling each other. Remember that opposite coefficients only cancel if you add them together. If I have a positive 1 and I add a negative 1, that's when they turn into a 0. Okay, but I can't just add the x's and move along my way, right? I have to also then add the y's and I have to add my constants over on the other side. So I always draw just a big, huge equal sign. And I just add all the like terms. All right, so x's, cool. They canceled each other. That's the whole point, right? I want them to eliminate. Then I have a 3y plus y, so that gives me a 4y. And I have 10 plus negative 10. Hey, those are opposites also, aren't they? Those cancel to give me 0. Then I can divide by 4, and I get y equals 0. Don't freak out if you get a 0. 0 is a number. It's okay. We'll talk about special cases later too, which is going to have lots of zeros involved. It's going to really freak you guys out. But bear with me. 0 is okay. 0 is a number. Then pick one of your original equations. Doesn't matter which one. I'm going to pick the one that I didn't change. So negative x plus y equals negative 10. And I'm going to use substitution to plug in that y value that I just found. So negative x plus 0 equals negative 10. Hopefully you guys agree with me when I say 0 doesn't matter. So negative x equals negative 10. And the x isn't quite by itself. I need to divide by negative 1 and get x equals positive 10 for my answer. Okay, so let's write our solution before we forget to do that. So our solution should always be xy, which means our solution is going to be the point 10, 0. And I always like to put a box and some stars so that I remember that's my actual solution, right? I did all this work to get to that. And now I still have to also check my solution. Okay, so let's do our check 1. And remember, when you do your check, it always, always, always has to go back to the original equation. So let's move up a little bit. Go back to the one you had before you multiplied. So negative x minus 3y equals negative 10. Okay, I'm going to get rid of this marker because it's not showing up very nicely. Make sure you're writing the original equation because I need to see what you're plugging it into. Because if you're making a mistake just plugging it in, as opposed to a mistake of actually simplifying, I need to know what the where the mistake's happening. Okay, so negative 10 minus 3y, so my 0 equals negative 10. So I get negative 10 minus 0 equals negative 10. Negative 10 equals negative 10. Bam, I am good with my first check. Then I need to do my second one, right? Check 2. So write your original equation, negative x plus y equals negative 10. And we get negative 10 plus 0 equals negative 10. Negative 10 plus 0 equals negative 10. And we get negative 10 equals negative 10. Check. We are good. So our solution here for this problem is the point 10, 0. Okay, so that's the first type that we can have where we have to multiply. We lucked out that some of the numbers were the same, it's just that they were exactly the same. So if we multiply by a negative 1, then it turns them into those opposite coefficients for us. Okay, but now take a look at page 17. Okay, if you take a look at page 17, and I know we started to talk about some of them in class, but let's actually look even just at that very first example. All right, 3x plus 5y equals 25. X minus 4y equals negative 20. Well, when we look here, none of those coefficients are the same, right? On the last one, at least we had negative 1 and negative 1. We turn one of them into a positive, we're good to go. But for these, none of them are the same, right? So we have to figure out how we're going to solve this one. So I'm actually going to grab an extra piece of paper here, and I want to write down this problem, and then we're going to solve this one together. Okay, so 3x plus 5y equals 25. I suggest you do the same thing, right? Make sure you're going to have enough space. So grab an extra piece of paper, hit pause if you need to, and then come back to it and rewrite these two equations for us. Okay. So 3x plus 5y equals 25. X minus 4y equals negative 20. So we have a lot of different options for solving this problem because we could cancel x or we could cancel y. Sometimes it just depends on what you happen to see first. Okay, so let's go with canceling the y's first. And then I'm going to do the same problem and I'm going to show you guys that it's okay to cancel the x's also. But I think most students look at this and they see that the 5 is positive and that the 4 is negative. Well, that's cool because then at least I don't have to worry about multiplying by negative signs, right? I just have to worry about multiplying by some numbers. Well, since this one's a 4 and that one's a 5, I'm just going to make them trade places. So watch what I do. This first equation, since it's already got a 5 in front of the y, I'm going to multiply all of it by 4. Okay, because that's what was in front of the y in my other equation. Now look at my second equation. Right now, it's got a 4 in front. The other one had a 5. So I'm going to multiply by 5. The reason I'm flip-flopping these is because that means then that those y's are going to now have the same number in front. Because I'm going to distribute this 4 inside to every piece. Okay, I'm going to rewrite my new equation over here. So 4 times 3x gives me 12x. 4 times 5y gives me 20y. And 4 times 25 gives me 100. Can you guys see that? There we go. 12x plus 20y equals 100. All right, let's look at our other equation. I want to take this 5 and distribute it everywhere inside. So all 3 pieces. Remember, when you distribute, when you multiply an equation by a number, we're distributing to all 3 pieces. Okay? So now we have a 5x minus 20y equals negative 100. There's my two new equations. Now look at them. Hopefully you can see that I have a positive 20y and a negative 20y. Okay, I got that because all I did was flip-flop my y's here. This one had a 4, so I multiplied the top equation by a 4. This one had a 5, so I multiplied the bottom equation by a 5. And by doing that, I turned them into opposite coefficients. They were already one positive, one negative. So all I had to do was make them to be the same number. All right, I made them both into a 20, and now I can solve it. So remember, the only way to get those to cancel, though, is to add, which means I have to add everything else together as well. Okay, draw your big, huge equal sign. So 12x plus 5x gives me 17x. 100 plus negative 100 gives me 0. Oops, I didn't mean to give you another one that gives you 0. Sorry, guys. Bear with me. Divide by 17, and we get x equals 0. All right, we're halfway done. Now, you have a couple of different options. You can go to one of these equations to plug in your x and solve for y, or you could go to one of your original equations. All right, I'm going to go to the very first original one. So I'm going to go to 3x plus 5y equals 25. Okay, I'm going to take that 0 that I found, and I'm going to plug it in for x. So 3 times 0 plus 5y equals 25. Hopefully you guys agree 3 times 0 is 0, which means that whole thing doesn't matter. And we get 5y equals 25. And then we can divide by 5, and we get y equals 5. Which means our solution to this equation, this system of equations, is 0, 5. That's our solution. Okay, now we do need to check it. We need to check it in our original equations. So let's do our check one right here. Our first equation was 3x plus 5y equals 25. So 3, take out the x and put in 0. 5, take out the y and put in 5. 0 plus 25 equals 25. So we get 25 equals 25, and we are good. All right, let's do our second check. Our second equation, go back up to your very originals. X minus 4y equals negative 20. So x is 0 minus 4 times y is 5 equals negative 20. 0 minus 20 equals negative 20, and we are good. Negative 20 equals negative 20. Awesome. So that is that solution to that first example that I gave you guys on page 17 that we didn't actually solve in class together. Okay? So I told you guys there's lots of different ways to do it, right? So if that multiplying by 4 and 5 really didn't make sense to you, let's take a look at another possible way to do it. Okay, so if you've got another piece of paper, go ahead and grab it, or if you've still got room on the paper you were writing on, that's cool too. And I'm going to go ahead and rewrite those original equations. 3x plus 5y equals 25. And x minus 4y equals negative 20. Now some of you might have looked at this and gone, ooh, all right, well you have a 3 and a 1. So if we could turn this 1 into a negative 3, then the x's would end up canceling, right? So let's do that. Let's multiply the bottom equation by negative 3. And that means then that I get negative 3x plus 12y equals positive 60. And then my other equation doesn't have to change at all. 3x plus 5y equals 25. All right, now this time I only had to multiply one of my equations. If you're comfortable with the other way that I just showed you, you don't have to keep watching this video. You can stop and you can continue with some of your practice. But if that first way didn't make sense to you and this is what you saw first, then let's continue with it. Now we have our opposite coefficients, and we get 17y equals 85. Okay, remember we have to add our other pieces together also. And then let's divide by 17, and we get y equals 5. And we already know that that's the same y solution we got before. Okay? Then from here, pick an equation. 3x plus 5y equals 25 was our first one. So let's do that. 3x plus 5 times 5 equals 25. So 3x plus 25 equals 25. Let's get rid of our Snapchat buddy. Ooh, we get 3x equals 0. Uh-oh. That's okay. We can still get rid of our best friend, right? We can still divide by 3. And we get x equals 0. So our solution, just like we found on the other method that we used, is 0, 5. We could also, if we want, take these two equations and put them into slope-intercept form and graph them, and they would cross at the point 0, 5. We could also, if we want, use substitution, right? We could easily isolate the x in the second equation and use substitution, and we would still get the solution 0, 5. So there are a lot of different ways for you to go about doing it. All right, in this particular section, we're talking about the elimination way. So either multiplying by the -3 here, or the first one that we did, which was multiplying by the 4 on top and the 5 on the bottom. There's other options as well, but those are usually the most two common ones that students see first. If there's something else that you see and you want to talk about and see if it makes sense, then either ask me or Mrs. Jennis or go to the MRC, and people will be more than happy to answer your questions. But I hope that that makes more sense. Remember that we are going to have a quiz on all three solving methods, so graphing, substitution, and elimination. So please make sure you're ready for that. And I will see you guys later. Bye!